assignment we were given 15 code, and we have to write a Python code to select any one of the protein structure. So here I have created a list, and it contain all the 15 structure as mentioned in the assignment, and using a random module, uh, this is a simple code that is going to choose any one of the random protein. As you can see, total 15 protein are here in the list, and 1HNG, this is the protein. To download it, will go to the RCSB website, and we are going to search this protein. This is the basic information about the protein that is given in the website. This is a 3D structure. We need to download the PDB file. So the PDB, the file that we have downloaded. Now we'll open the VMD. The first thing that we are going to do is set the working directory of VMD as extra folder. So the current directory is this. First we'll go to the root folder by this command, and here we can see that our file is in the download folder. Now we'll go inside the extra folder. So we are in this directory where our file is. We can clear the commands. To load the file into the VMD, we can use the command mol followed with the file name. Now our file is loaded into the VMD. Now we'll go to extension, graphic representation, and create another copy of this where we are going to store only the protein. Coloring method, secondary structure, and lines. Drawing method should be new cartoon. Now if I remove the first one, we can see the protein clearly in the console, in the display. We want to store this protein in a PDB file. For that, we first need to select all the protein that we can do using command set select. Atom select. Top protein. Now we are going to write this in a PDB file. So we have selected the protein, and we have written that data into the PDB file. Let's delete the molecule from VMD now. And load the file that we have created. So it is loaded into the VMD. We have already created a PDB file and we need to create a PSF file. In order to create the PSF file, we are going to go in extension, then modeling, and then in automatic PSF builder. This is our input file and this is going to be the name of our output PSF file, new P auto PSF. We are going to load input file. This should be in everything, gas and split chain. Then create chain, and finally apply patches and finish. So our file is generated. It is in the prompt also. There, the software is saying it. Now we will load our file that we have generated. So we'll delete the existing file. And then we are going to load the file that we have just generated. So the PSF file is generated. Okay, let me load the file again. I did something wrong there. Mol delete all, then mol new P auto PSF dot PSF, then mol add file new P auto PSF dot PDB. So this is the file. We have loaded the PSF file, and here also we can see the number of atoms. Now we will be adding water. For that we have to go in extension, then modeling, then add solvation box. So our PSF file is this, and our PDB file is here. As far as the question, we will be setting padding as 20. Now we are going to run the simulation. And this is our protein, and it is not surrounded by the water molecule. So now we are going to again delete the file. And then we are going to load the solvate.psf file. Now we are going to load the solvate.pdb file. if I want to check the box size, then I can check it by PVC get. So this is the box size, ABC, as well as their angle. All of them are written here. So now we are going to see the charge on both protein as well as the water that is surrounding. So in order to do that, first we will select protein as cell 1. And then we are going to select the water as cell 2. Okay, I missed the space there. Now we have selected both water as well as protein as cell 1 and cell 2. If we want to see the charge, we can use the command eval vacat dollar cell 1 so and if we want to check the charge in our water molecule, we can use the command so both of them are neutral. If we want to neutralize, we'll go to extension, then modeling, add-ons. We'll have to browse the solvit.psf file and solvit.pdb file. As far as question, this is 0.5, and then we'll press. It's done. Now we'll delete the present molecule and load the new one. This is our PSF file. And this is our PDB file. If I want to see the charge on all the system, so here I have selected the entire system as 3. To see the charge, so this is the charge. It's very small, it's almost negligible. So our system is neutralized. After doing this, we need the center coordinate as well as the periodic boundary coordinate. To get the center coordinate, we can use the command measure center, and for the PVC coordinate, we just need to write PVC get. Now these two coordinate are very important because during the Paramananda solver, we are going to change these coordinate in the minimize file. Now after this, we need to open the WinZip. This is the directory that is on my PC, while this is the directory on the server. Now I have already uploaded the file which is given in the classroom, and my ionized.pdb and psf file also I have uploaded here. Now we need to open minimize.config file, and we will be changing certain parameter here depending upon the result that we got. Now the first thing that we need to change is these force field parameter. The directory here needs to be similar to the directory of our folder. So I have already changed these. The second file that you need to change are these periodic boundary condition. Now what we need to do here is we'll change cell origin coordinate as these coordinate, center coordinates. And vector 1, vector 2, vector 3, here we need to write PVC coordinate like x, y and z, or ABC we are going to put in this way. This is the x. So here this coordinate we need to place here. Then the second one will come here. And the third will come in this. Now these angle we need not to change. Now we can save this by pressing Ctrl+S. Now these parameters have been changed. Now we need to open the MOBA extra. Here, before starting, you need to check two things. The first thing is you have to check whether the module NAMD3 is loaded or not. How you can do it? What you can do is write module list. That will give you the list of the module that is already loaded. If NAMD3 is not loaded, then use the command module avail. That is going to show all the module available. Then using module load command, we can load NAMD3. The second thing is we need to navigate to our working directory. Now that directory will be similar to this, where our folder is. So there you have to navigate to the directory, and here if I write ls, then I can see that my files are already here. Now we have loaded the NAMD3 module and we are on the working directory also. All we need to do is run the simulation. To run it, we just need to write, we need to write the login password. No, it's already login. NAMD3 minimize.conf. So this is going to run the simulation.